Welcome to our February version of the Mathlib community meeting. I hope everyone is doing well and comes here with a light heart and a positive outlook for the future. So what I've done is I've just collected some questions that have popped up through different venues, and I thought I'd pose them here and try and get some broader feedback. Some of those posing the question may be left anonymous, but I'd appreciate people's honest thoughts on things. And so I don't know where you are, but here spring is poking through, and we're in a season of growth, renewal, a lot of growth. And so someone posed the question of what would it take to 10x Mathlib? And implicit in this question is, what does that mean to you? And so I'd like to open the party here with that particular question, right? What would it mean to 10x Mathlib, and what would it take in your mind? What are the key factors to make this happen?
I would say like loads more number theory. That would be great. Unfortunately, that would take right now. It would take lots more humans involved, which is really difficult to arrange.
Any particular types of humans?
Yeah, I mean, people like us, unfortunately. People who somehow managed to find the time to goof around with Mathlib while simultaneously, being professional mathematicians.
I mean, 10 times the PRs would have to be merged. So more reviewers also.
Yeah, there's a weight of PRs upon us at the moment. So
yes, we can't even handle Mathlib growing at its current rate, so let alone 10 times the rate.
what is it? Just 10 times the lines of code, or I'm sure you could get an LLM to spit out things that are type checking, right? But that mathematicians would look at and view as, drivel in terms of actual real mathematical content. And I think the phrase peak data has been thrown around, where we've already consumed all the data. Maybe not we, but people training these models have already consumed all the data that exists in our current electronic form, and they have to figure out how to find more. And so they turn to what else but their most efficient ways of generating data, more LLMs, and then you end up in a situation where have a vicious feedback loop.
I mean, I would also argue that a good way of growing is by avoiding duplication. That for humans is obvious the case that it's duplicated, but not so much when you're formalizing things. And I'm thinking of all the with bot, with top, less than or equal, greater than or equal, min, max, all of these things. To a human, you just say one of the two, and almost surely it'll be able to guess the other one. Whereas with the Mathlib, everyone is duplicating, quadruplicating, octuplicating all of these lemmas. So 10 times the growth might be develop tools that allow you to not have to duplicate, but half the size of Mathlib.
Yeah, I mean, I totally get that sentiment, right? Because as people, we're very good at unifying a lot of concepts in our brain, even if the unification is a little fuzzy. I don't know if I necessarily believe that that's possible in any computer system, just because when you get down to precise details about things, they are different enough. And then above that, if you're going to ask Lean, say, to unfold and unfold and unfold till it gets down to a statement that is clear for that underlying unfolded term, you're going to ask him to do a lot of work in the interim.
We're also
complicated
asking
example
to,
of this
yeah.
is sorry.
Dagger, do you want to go?
Yeah, I mean, there's a more complicated example in category theory with limits and co-limits. It's
You wanna-
essentially the same thing, but it's like even harder to imagine how to make automatic dualization of that.
Do you
Because
want to
have to
expand a
turn-
bit on that for the audience?
I mean, you get like, for example, you have to decide which morphisms to turn around, what associations to move around, and so on.
Maybe a slightly in between example would be duality of vector spaces. Like every time you have an assumption this map is surjective between vector spaces, you have a dual statement about the map being injective, and that is some form, I think, maybe in a more elementary context of what you were saying.
Yeah. But even, I mean, the first step is, like you mentioned, like min-max, stuff like that. We can't even do all that automatically. So
I mean, I
And there
agree,
are more
but
layers
I
on
agree,
top.
but we also can't grow Mathlib 10 times
Yeah.
between today and tomorrow. So
Well, but let me take a tack on this. All right. Let's say I just wrote much better deriving handles where I don't just derive, say, instances, which I can't do right now for basic type wrappers or more complicated types built out of types that are familiar where we can figure these things out. But I can also derive large swaths of API that duplicate all the familiar tools from one realm to another. This could also potentially 10x Mathlib. And I think it would ideally make everything actually run faster and make people's jobs easier. Because when Lean doesn't have to float around unfolding stuff and unifying things that are complicated expressions, when it can just go straight off the term itself, type itself without unfolding it, things tend to run much better. But the problem is no one wants to sit down by hand and write out all these obvious things where you wrap one type in another and then you say, okay, well, because we can add on this new type, et cetera, et cetera, et cetera. So what do people think about that as a idea and also the feasibility of doing something like this?
So sorry, to be clear, you're asking about what would be the benefits if you could just create new type wrappers easily?
Well, I think duplicate in a non-exact sense, but to promote, say, existing instances, existing methods, existing API from fields in your type to the type itself without having to, in a proof, say, oh, let's break this up into its pieces and use the API down below, right? So, don't go down from polynomials to FinSup, right? Just push one button or make some nice hash incantation. And now all the API you want for FinSup is now API for polynomials with the correct namespace, the correct types, so that Lean can just say, yes, I don't have to unfold polynomial. I know exactly what this is supposed to be doing, and it does that. This would certainly 10x Mathlib, I would think. And I think it would make our lives a lot easier in many ways.
I think it's much easier to reason about these or hope that these tools solve all your problems when the tool doesn't exist yet. I can tell from experience with the additive that like it takes a lot of work to get all the edge case, like to get all the cases you want. And even with the additive, there's a whole bunch of things that it doesn't do. For example, like translating from powers to scalar multiplications. That's still hard, just because the argument order is different. And that's the only. I mean, it's a trivial case, but somehow that still makes it like way more complicated. And the additive can do a few easy cases, but like. I think all these automatic translation that would be very useful to have a tool that can dualize orders and do all these like trivial duplication, like get rid of some of the trivial duplication of Mathlib. But I think for a large part, I think that is only a small part of the puzzle, of the bigger puzzle to grow Mathlib.
Do you want to identify the other bigger parts, perhaps,
Yeah,
or
so
comparable parts?
I think another part was already mentioned, and that is reviewers, and that they're not quite sure what to do. Like, so when I've given now 2 years a course teaching students Lean, and after the course they can write Lean code that compiles and proves new things. So from there, going to having them write Mathlib ready or approximately Mathlib ready code is still an enormous step. So there, I've one bachelor student that did their thesis with me last year, and now she's still working for me last semester. And now she is so this is Hannah Schultz, who has now like made pull requests and put CW complexes in Mathlib. So that is great.
Yeah.
But that is already like significantly more work to get them to that level. And then ideally we want to also transition like Mathlib contributors to Mathlib reviewers. And we're already partly doing that by just encouraging anyone that has contributed a few things to Mathlib, hey, look at another PR and review it. But perhaps we can, I don't know, make this progression more easy in some way.
And what do you think would do that? What
Well-
structure? Yeah, Kevin.
Heather said to me recently that the way she accelerated her learning was she made PRs and they were reviewed promptly because this community was much smaller back then. And so she got very quick feedback from Yuri and from Sebastian that enabled her to level up very quickly. And now we can't do that because there's over 1,000 open PRs. And somehow there's 10 times as many open PRs and not 10 times as many reviewers.
So it's a virtuous cycle, but it has to start.
So as somebody who became a reviewer somewhat recently, I think there is this gap from being able to review simple PRs to reviewing difficult PRs. And that transition is not so clear to me because there's lots of implicit knowledge. When should arguments be implicit? What are the proper ways to design this part of the library? And these things are, I think, hardly documented. I learned them by getting them wrong, getting burned, and then talking to somebody who knows Lean who tells me, oh, do it this way. I think if we want to scale, we need to scale to the level of designing libraries properly, because having a handful of experts is not enough.
I think it would also help to have more informal rules written down. I think very often we have like a discussion on how we do something, and then we have mostly made a decision, but maybe not completely, and then it's definitely not added to the style guide or naming conventions or the other documents. And so I think, yeah, making sure that we keep those more complete might help. Also with just telling reviewers like what to review for. And And more linters. So I think in the last few days I was a bit critical about the linters because they were slow sometimes, and I think it would be very nice to be able to turn them off. But actually, like having, for example, an auto formatter, I think that is someone has to work on that, because that is like now getting somewhat bad that we don't have that, and we're spending like reviewing time on people getting spacing errors or something.
I'm just taking the moment to write things down as notes a little bit belatedly. So my memory's not very good. It's getting worse by the day. But where are the current formal or informal bodies of knowledge that we want to communicate to reviewers put and share right now?
I mean, formally, the naming convention and style guide, I think, on the Limburger community website are the main sources. And then there's a whole lot of like accumulated reviewer experience that is not written down.
There are also reviewer guidelines, which are an explicit document, which is sent to every new reviewer. These are really helpful, but they stop when it gets to the interesting and difficult pieces. So that part is missing. I think Yale mentioned they were writing a career guide to reviewing or something. I would be really interested in seeing that happen, both on the, let us say, low-level technical advice. This GitHub feature you ought to know because it will make your reviewing 3 times faster, things like that, but also on the higher level things. Yeah, I remember also there was some Zulip thread where we were collecting things of informal knowledge that needs to be documented. Even just going down that list and making sure each of them was documented would be great progress. And I can dig that up.
Yeah, that's what I was about to say. If someone could dig that up in the interim here, that'd be helpful.
There's also a very small number of library notes scattered around that I don't think are very much used, but I think they could be very useful.
Are those still collected and put somewhere on the web page?
I don't think so. I don't think DocGen does this anymore.
Okay.
But that would be good if it did.
Yeah. I mean, I guess one of the things you could say is that we're gonna sorry, I'm still writing at the same time. I should really have someone be a scribe instead of me. One of the things you could say is that this will all be fixed by Verso at some point, so why should we futz around? But yeah, I think I agree. I think easier discovery for these kinds of common knowledge questions would be much more helpful.
I think we also just need to have more tutorials for various things. I mean, some of them are well documented and like occur in mathematics and mean, for example, like forgetful inheritance and like transferring, like creating a metric structure, but then transferring over the topology and Bornology. And some of these things are really common and done a lot. But like some other things are just a lot less obvious, and I don't know. I don't see a way of getting around having. Well, I don't know. There's this thing that came up recently. I was working on the Holder inequalities, and Flores and Yuri mentioned, oh, well, you should do it like we handle convolutions and just take an arbitrary bilinear map. And this was a great thing, but it was one of those things that's like not obvious unless you've played with the convolution approach already.
Mm-hmm.
So like it would be good to document that kind of thing somewhere too, but yeah, I don't really know where to do that.
Mm-hmm.
Yeah, I guess that makes sense. I think in this case, convolution is sort of the first time we do that generalization, but if it if like some kind of knowledge shows up multiple places, then it would be great to like document that in a library note somewhere. I think these library notes are quite useful because they are quite flexible, and you can put them anywhere, and like it can sort of in a decentralized base accumulate knowledge. But of course, we still need this tool that displays all library notes. That would be useful. So I think just, yeah, I mean, we talked, I mean, there are some hidden discussions in the maintainer team about money right now, which probably we shouldn't go into the details, but it would probably be good to have like, I don't know, hire an engineer that just can polish the documentation, can write like more connections between things, and how to precisely fund that is maybe not a discussion for now, but maybe like what kind of tasks we want to be solved might be interesting to discuss now. Like,
Yeah.
or collect a feature list of someone that maybe doesn't know Lean, how they can contribute. That with an open source project, maybe if just having that list means people are already willing to contribute if they think what we're doing is cool, but they are just starting to learn Lean.
So I met Dan Abramoff yesterday at Xena, and he said that he thought that the Lean Zulip community was very welcoming, because in other programming communities, sometimes when you ask basic questions, you're just told to go and read the fucking manual. And I told him that we don't say that because we haven't got a manual. That's why we have to help newcomers. So I think one interesting question is, let's say we have access to money, then how can money solve problems?
Here's a crazy idea. Maybe not too crazy. Kevin, do you remember these Simon symposiums they used to have, where they'd put you up in the Caribbean for a while? So what if, I mean, maybe not a Simon symposium. What if we found a very nice venue and had a conference that was just about up-training reviewers, where you got a bunch of experts in reviewing, and instead of having these once a week or bi-weekly Q parties, the goal there would be to just take down the queue as much as possible, but do it in a process where we brought people who are contributors or already reviewers up to the next level in that skill.
Yeah, I think that would be useful. Also, to answer Kevin's question, like if I suddenly have a bag of money, like I could, I don't know, hire all students of my Lean course as like student research assistants, at least all the ones that want to, and ask them to formalize whole X in Mathlib or something.
But they don't. But then they write crappy code, right?
That is true. So I mean, but there. I currently have a sample size n equals 1. I did it with Hannah Schultz now, and we now have CW complexes in Mathlib. So I mean, it is possible. I don't think the success rate of 100% that I have now will continue. I mean, actually, I should maybe stop now that I keep a success rate of 100%. But I think that this is a feasible way to get more Mathlib contributors. It's still to be seen if this is then a feasible way to get more Mathlib reviewers, which is currently the bigger bottleneck, because me just generating more Mathlib contributors exacerbates the other problem we have.
So if we're talking about reviewing, the Qboard tool, I think, is in the stage where it only has a lot of promise, but there's lots of ways in which it could improve. So there is a survey. If you have a particular need, please fill out the survey. It would be great to know what should come next. But for some of these technical challenges, it really shows that neither Johan nor me are computer scientists. So I think a trained computer scientist could just take one of these easy technical problems we have, knock them out in a day, and make all of our life great.
Is there a list of all issues with the keywords that you are all feature
an issue list? I mean, there are a few more issues in my head. So if you have somebody who wants to work on this, has an idea, funnel them to me. I can give you lots of ideas. I think the hard part is knowing that there's somebody who has the skill set to do them. Right now, I'm not writing them down just because it's not clear if anyone works on them. Like some of them easy technical issues. How do you work with GitHub webhooks to make this thing happen? Might take 5 hours once, would transform the keyboard completely. So if you know somebody, please, that's an easy way to know.
I mean, I think the infusion of people like Dan Abramov and others who have vast technical knowledge but aren't lean experts is a real opportunity we can't afford to miss out on by not providing concrete things that really fit into their wheelhouse and help them get familiar with the language, but at the same time help us where we have, you know, our blind spots, our weak points. Because if you start with a mathematician and try and make him a programmer, there's a whole body of knowledge that you just don't have, right? A lot of mathematicians don't have that training. So it's not an easy thing for them to bootstrap their way up. All right, any more thoughts on stimulating, promoting, supporting Mathlib growth?
I mean, just because nobody's mentioned it in this meeting yet, more tactics, just tactics that can do domain-specific automation, things like positivity, fun prop, things like that. I think all of those are amazing. And we need a lot more of them.
So Heather is running some kind of tactic study group at Imperial right now, and I think that there's very little to learn from. Like, if you want to learn how to write a tactic, there's like some great videos by Rob for Lean 3. You know, is that really the best that our community can actually offer right now? Is that literally the thing we can offer? Some like videos from an old system and nothing, and the meta programming book.
There are the videos by Siddhartha. I think they are pretty good.
Yes. I'd forgotten about those. The videos by Siddhartha, yes.
Where can I find those if I was going to look for them?
It's somewhere in the Zulip, right?
Let me see.
We should have a Zulip thread with everything that is contained in Zulip threads.
Wait a minute.
So a few months ago, I did a few sessions on meta programming here, but indeed there was little material to take from. Soon and already now, there is more material in the reference manual, but of course the reference manual itself is not a good place to learn it for the first time. But the reference manual could be a great source to write learning material because the reference manual sort of contains all the information, and that has to then be presented in tutorial or textbook forms.
Jeremy.
Yes. Yeah, actually, I find that the lean for reference manual is I am partly tagged on GitHub. You know it, right? The lean for reference manual is it feels like it feels like it wasn't written for Mathlib at all. Maybe there should be more Mathlib examples in the lean for manual. More actual mats in there.
I think that should be a different document. Like the reference manual is a reference manual of Lean. If we want more maps, we need a Mathlib reference manual, which maybe is actually a great idea, but it should not be like part of the Lean reference manual.
Yeah, but even well, I'm finding that even that Mathlib specific reference manual does not exist yet.
Well, this is probably what mathematics in Lean is going to become at some point, but it's going to take a lot of work.
Yeah.
Yeah, I don't know. I think like mathematics in Lean is a source for learning, and it's much less a source
Yeah,
for
right.
reference. If you already know how to formalize in Lean, you like reading mathematics in Lean will still give you some information, but it's not intended to be a comprehensive source of information. Where like if you're brainstorming about a Mathlib reference manual, it should be something like, we have a chapter on linear algebra, and it should contain all the definitions in linear algebra. Maybe not all the lemmas, that might be a bit too extreme. I mean, then you get like the Mathlib docs that we have right now, but all the, I don't know, almost all the definitions and how to work with them. But is a document like that doable to write? Is it duplicating too much the module docs? Maybe we can just generate something that is useful or automatically already from the module docs, but maybe not.
I think actually maybe the module docs and then a bit more might be enough. I'm actually on my phone right now because I'm actually training an AI of a completely different purpose on my laptop. That's why I'm on my phone. I'm actually training an AI for the company that I work at right now, which is a train company. And I expect it to take about
That's no problem.
about 16 hours.
I'm not exactly sure. Like, you say Mathlib reference manual. Of course, that would allow us to solve Kevin's problem when we have new members. But even the scope of it is a bit nebulous to me in terms of what goes in and what comes out.
Maybe you should just concentrate on say. I mean, we should keep the mathematics. We should keep the mathematics in that hypothetical manual, fairly at like undergraduate level. Maybe just handle linear algebra and the combinatorics, especially graph theory. Because once you know how to do such a thing, then you can the rest, like real analysis or category theory, which I never learned in university, it becomes quite easy.
I mean, maybe just having expanded or sort of tutorialized versions of the tactic folder. You just pick a tactic and you write a tutorial explaining what the various steps are doing, because a lot of tactic writing is basically copying over something that has been already done somewhere else. And just sort of going through one tactic and saying, oh, this is what it's doing, but specifically for the tactics that are already in Mathlib, might be a good way of getting people to learn about tactic writing, specifically for Mathlib, not the tactics the core develops.
So I could revisit my. Oh, go ahead.
So coming back to that reference manual idea, here's an idea that might be an 80-20 solution. So for each, say, Mathlib directory, you just write a short overview file that perhaps auto-generated contains all the important definitions, that contains all the library nodes defined in that folder as some rough proxy of here the important design decisions, and contains all tactics which are relevant. So that's this virtual prototype generating, like collecting the tactic documentation with some manual annotation of this tactic is relevant for this order, for this folder. So if you have this information manually maintained for each top-level directory, you could just generate that. I think that wouldn't be too much effort to maintain once you've generated it once, but that could be like a good way to start.
Yeah, I think a good start would be great, no matter what approach people take here. If we want to find a nice location for people to get together and focus just on upskilling people for tactic writing, find some experts, find some problems, and then collect the materials from that and put them someplace prominent. I think that would solve a few problems. Hopefully you get a few people out of there who are really prepared to address questions that are pressing for Mathlib, or even maybe more broadly. And two, you would put recent, relevant, and broader information in a single place that hopefully is consumable and people could use it to improve their skills on their own. I mean, we had a workshop on cohomology and burrs at some point, and that was a very specific aspect of Mathlib. It makes sense to try and have other workshops, especially ones that could generate useful tools, useful tutorials for the community more broadly. All right. Any other ideas on this topic? I'm sure people have many. So here's another question that recently came up. Suppose I am teaching a class, and this class on Lean will involve some projects. Right? And let's leave the skill level or the educational level of the students to be unspecified for the moment. Where can I figure out a good list of suggestions to share with these students that will help them orient themselves and get a firm start on such a project? I realize this is heavily dependent on the student's level, but feel free to answer for any level you instantiate.
We've got this. We just started this 1,000 plus theorems project, and maybe you can actually you show these students the code from this project, like my own proof of Turan's theorem, or maybe even Pimot's ongoing proof of Tuts. You show them some simple theorem and how it is proven Lean.
Okay.
So that's how I teach my class. I give a bunch of these. I mean, I choose an area like basic analysis, series, whatever, sequences, limits of sequences. I prove 5 theorems, and all the way through, I write a line of English, and then in a comment, and then a line of Lean under it, saying, and the comment says what that line does, and then I give them 5 more for them to do themselves, and then I run labs where they come along and they're stuck and they just ask me questions, and me and my PhD students just tell them the answers.
And you find that effective?
I mean, for those that come to the labs, it seems to work great. But I have a big team of people. I mean, Bavic's running the course now, but it's Bavic, me, and like 4 other people just show up and up this room full of people. So it's sort of easy once you've got a big team.
I can remember, and when I was an undergraduate, I'd actually think I'd actually attend basic programming courses. I had to wake up at 6 a.m. Just to go to university on the other side of Singapore, and then to NUS, and then these sessions were a bit more often than not they turn into some drudgery. So, well, I do appreciate what this lab approach is. The performance of this lab approach. There might also be some you might encounter more than a few disagreements with this kind of teaching.
Well, teaching is very individual.
I mean,
One thing, do we need to restrict? One thing I heard from Kevin, though, is he restricts to an area to begin with, right? And we say, okay, we're just going to talk about analysis. And then students are stunted into this area.
Right.
I
We,
think
Yeah,
we
we
just
just hop
always
between
restrict to an
areas.
area.
We just hop
Try,
around like
try
we
and
do.
always restrict, because otherwise they will.
Okay, let's.
Those students
Well,
might get a
sorry,
bit.
sorry, Jeremy. I think Kevin was talking.
I mean, we do a week on analysis, and then we do a week on vector spaces, and
Okay.
we just do bits and bobs like that.
And I think I interrupted Flores also by speaking.
yeah,
Is
I
that-
mean, I think that like, okay, it's a little bit tricky to generate a list of topics, but actually, if you give students like the library overview, and they sort of probably usually already have an idea what to maybe in what area what to search for, like I think they generally can find a topic without too much effort. Also, my experience is that for first-time Lean users taking a course, it's very hard to get anything to Mathlib. So I'm not sure if it really would be worthwhile to have like sort of a centralized list of like project topics, especially because like it changes like every week, which topics are like appropriate for the current level of Mathlib. Like I definitely had to change from last year to this year, like what projects were good.
Could maybe
Jeremy?
the proof wanted?
sorry.
I was wondering just whether the proof wanted could be used for this thing, because that at least updates itself. If someone removes a proof wanted, no one else will find it afterwards. So maybe there should be more proof wanted in various parts of Mathlib for results that people would like to have and didn't have the time to formalize or didn't know how to formalize. But not necessarily big results like Fermat's last theorem, but also sort of smaller things. I don't know, the eigenvalues of this matrix are whatever, or some simpler facts that you could in theory formalize, you just didn't have time to do it, or you were planning to do, but then you didn't do. That might be useful.
How many occurrences do we have right now of proof wanted in the library?
I think proof wanted would also require an indication of how much work it is, because it's quite easy to write some proof wanted that would be like a 5-year research project instead of a 3-week or like 2 months student project. And maybe from a beginning student, it might not be clear that which is which.
I think no matter who is beginning will need a fair amount of guidance anyway. So, but I agree. Maybe proof wanted must have maybe sort of required to have a field where you give a level of 0 to 10 to judge its difficulty or something like this.
Julian.
I was just recalling that a bunch of modules have to-do sections at the top. Is it worth maybe going through and seeing how many of those can be turned into project wanteds? Like in the Markdown? I don't know how common it is anymore, but I've definitely seen them.
So some of my students took like as a project a to-do from like a Mathlib module. So I think those could be nice to like keep track of more of them.
My possibly erroneous grepping says we have 41 proof wanteds in going off the root directory, and we have 1,890 to-dos going off the directory. So I think that's a reasonable thing, is if people wanted to go through these to-dos and figure out which of them are reasonable. But I don't know what our policy is at this point about having proof wanted in the library to begin with. And if anyone could share some insight, that would be helpful.
Wait, but with to-dos, I think you have to be careful, because sometimes it's a to-do because it has not been PR'd yet, but the people who are PRing that already have the code for it. So you don't have to be careful.
That's a very good point.
Yeah, but then again, if it's specifically about student projects,
Yeah.
it's honestly, if it's with student projects, it doesn't matter that much in my experience if it's duplicating code. It is somewhat nice that if it is duplicating code, that the student doesn't know it because they feel better about it. But generally, it doesn't end up in math. So at least for the first time when you're doing a lean course, like those kinds of projects. Later, of course, if you do deeper things, it becomes different.
But I think, oh, go ahead, sorry.
I would like to second what Eric wrote in the chat. If I have a project like define and prove some basic properties of Fredholm operators, as happened this semester, you need to define Fredholm operators first. And you wouldn't demand that we are just defining it without having also prove some properties.
Yeah, I think that's exactly the danger with these in having them in Mathlib, is that you have to be very careful about the scope and what having a concrete plan that is feasible to actually achieve it, so that you don't end up with a lot of broken off routes. So Eric says we could get a docstring linking to Wikipedia. But this also ties back in, I think, to the previous topic of growing Mathlib. If you have better discovery for the things that need to be done, then people are more likely to show up and do them on their own.
Well, to be honest, if the goal of these proof wanted, like of a new definition, is added to Mathlib with the intention that like new contributors that don't really know Mathlib are intending to contribute to them, I think this is not going to be going great, because I think defining like new definitions and API for them, especially if it's a new type or a new category of like object, I think that is very hard.
Yeah.
Like proving lemmas about existing things is generally easier.
I mean, I agree. Sorry, go ahead.
This is probably also the reason why it's hard to do these things, right? Because if you've done the definition, then it's easy enough to write the lemmas that follow from it. And so you're basically then stuck at the next definition. You stop there, and that's the proof one then. And so then someone has to go and think about the definition and all the API lemmas, and then they write the definition. They might as well write the API lemmas. And so maybe there should be a little bit more sort of flexibility. You write a definition, you're not completely sure it's correct, and then you write some proof wanted, sort of fleshing out what the definition is supposed to do. And then part of the game is to also figure out what was the correct definition that would have allowed you to prove those API lemmas you have afterwards. Or maybe not API lemmas, but maybe longer term goals given that definition.
Yeah, I mean, I think there's reasonable room for growth and usage of this in a way that doesn't accumulate a lot of debt, but we should probably be circumspect and sort of outline where we think it's appropriate, so that when people are reviewing things, it's not surprising what needs to be done. People don't have to try and figure out things on their own.
Right, but I mean, for a while there was the crawl dimension. I mean, it took a long time developing, but probably people knew what properties they would have wanted from any definition of crawl dimension. And I wonder whether maybe have the proof wanted around that you knew where part of the, and then if you can make a PR that sort of proves all of those things, then probably you've got the right definition.
Right, so you specify the API you want, in some concrete and somewhat exhaustive fashion. And anything that meets that is a reasonable candidate.
Right. I mean, maybe you're not guaranteed it's going to be merged right away, but you have a fair chance of having defined the right thing in the right way so that you can actually work with it.
Mm-hmm.
I think there's a quite technical challenge here of actually specifying this API. Because if you allow a definition to define what you wanted to be referenced somewhere, then it's now in the environment and people can use it. And so now it's either an axiom or it's proof with sorry. And neither of those is particularly desirable. Or we have proof wanted populate some secondary temporary environment somewhere. Maybe you have a proof wanted section, and then everything in the section gets thrown away at the end. And then you can use axioms and sorries whenever you like in the section. And then at least some kind of check at the end saying, does everything in the environment in Mathlib use only the standard axioms have no sorries? Then that would still pass.
I see. Yeah.
Yeah, like a without modifying environment for a list of commands.
Exactly.
Yeah, that's good.
Just taking that down too as a suggestion. All right. We're getting close to the top of the hour. So 5 minutes till. In the last few moments, is there anything else people want to bring up that isn't on these topics necessarily, or anything else more that people want to say?
If you've been looking at Matlib's PRQ, I've been submitting quite a bit of these so-called deep priming PRs because I really believe that in Matlib there are defined cases prime and induction prime, and I actually see that all of them can be actually replaced with things that are in lean core. But now Eric is saying that there is a certain syntax of induction prime that is not yet implemented in core induction, and we should actually wait for that to land before I remove such users of induction prime. But I don't. That thread.
I mean, I think in situations like this where there's reasonable opinions on both sides, you're going to end up at the status quo until one side gets convinced that the other side is correct. I do think the idea of deduplication is great, but with a lot of things in core, there's always going to be a certain amount of functionality that you want that isn't there. And you got to ask yourself, how much is it worth to build things on top of that to maintain it? So I think if people have opinions on that, Eric provided the Zulip thread, they can go over the opinions there and add their own.
I think there's also the argument, if core were to change, and it were to change soon, then it just kind of leaves more of a mess for us to remove these things and then core to change. So if core is going to add a feature that helps us clean things up nicely, then we should wait a little bit of time for that feature rather than cleaning them up less nicely, because we kind of lose the record of what we can clean up otherwise.
Yeah, that makes sense.
If core says, no, we're not doing this, then yeah, we revisit it.
Is there a tracking issue for core on this? Have they given a priority?
And Joachim have thought about this. So
Well,
maybe
the last time we checked, there was no thread. There was no IFC for implementing the functionality of induction prime into core induction.
Okay. Yeah, I think that would probably be a good step, is at least get it somewhere where you could get a formal response and then use that information to continue deliberation.
Because as I said, I myself don't know how to implement the missing functionality in lean core, because I'm also a bit afraid of breaking so many things.
Very healthy fear. I think we all have that, especially when you touch things in core that are essential. Even the people who are the absolute experts have that.
Luckily, we don't have merge right on that repository. So
what merger right?
I meant, I mean, it's right to be worried about breaking things, but you're not actually going to break it because you're not going to be able to merge the changes you propose unless they get approved by some of the core developers.
Uh,
All right, that's great. I think that's a great discussion we've had. We're running out of time, so maybe we can wrap it up here. Thank you for coming. Hopefully in
Okay.
2 months, we can talk about how wonderful grind is and how it's changed all our lives. It will continue the motif of things you can say in a hip hop song and things you can do in this
grind
language.
actually?
It's
What
a
is
beautiful,
grind?
beautiful new thing. Beautiful new thing. And that at
We
that
don't
point,
know
we need
yet.
to
We'll
stop
find out in
we
2
need to
months.
stop the recording. Yes, and then we can speculate more freely.
Yeah.
All right. Thanks everyone for coming.